Again, students. So we are dealing with the question number 9. As you can see, question number 9 is presented on the screen. 10 moles of an ideal monatomic gas initially is at a state A at atmospheric pressure and temperature of 27 degrees Celsius. It is enclosed in a metal cylinder of volume V0 fitted with a frictionless piston. The gas is suddenly compressed to a state B. So sudden compression means adiabatic process, definitely. So process A to B must be a adiabatic process, and it's the volume V0 by 3. Now keeping the piston stationary, the cylinder is submerged in a water bath of temperature 11 degrees Celsius until the gas reaches the temperature of water bath, which is denoted as at state C. Okay, then it is like a with this constant volume, that must be isobaric process. Isochoric process. Finally, while still in a water bath, the piston is brought slowly to its initial position. From that statement, we can understand as it is bringing slowly, it is an isothermal process. And yeah, it brought to final temperature must be temperature of the water bath, that is 11 degrees Celsius. If R is a universal gas constant, then correct options are. So let us verify. First question, they were asking schematic diagram. Let us see if this schematic diagram follows or not. As I was saying, process A to B is adiabatic process, quick process. Then process B to C must be isochoric process, constant volume. Then again from process C to F, it is definitely isothermal process. Now with these things I can say that, let me first derive the things. Process A to B process, adiabatic. What are we going to deal with over here? Let me take the given values. Number of moles is given as a 10, and what else we can say? Adiabatic ratio can be 5 by 3 for ideal monatomic gas. Now, as temperature at A is given, temperature at A is 27 degrees Celsius. That can be written in a form of Kelvin, 300 Kelvin, and temperature at B point I want to find. So how can we take a temperature at point B with the relation of what was that relation? T V to the power gamma minus 1 is a constant relation. From this I can write final temperature. Temperature at B can be written as temperature at A times of VA upon VB whole to the power gamma minus 1. If I substitute the values of 300 times, and VA is V0, let me say, VB is V0 by 3 as given in the question, and 5 by 3 minus 1 would leads to 2 by 3 times. And yeah, and that would give you answer of 624 Kelvin. So the temperature at point B when adiabatically brought back from A to B is 624 Kelvin. Now pressure also let us see. We know that P V power gamma is constant. With this relation, I can say that pressure at point B is equals to pressure at point A times of VA VB whole to the power gamma. Pressure at A is nothing but atmospheric pressure as given in the question, and volumes also we know that V0 upon V0 by 3 whole to the power gamma. And pressure at B, if I can substitute the values, gamma value is 5 by 3 times. Yeah, if I can consider like that, this would lead to 6.24 times of P atmospheric pressure. This is what I got. And one of the options they were mentioning, the pressure and temperature at state B are 2.08 times the atmospheric pressure and 624 Kelvin. Yeah, obviously the temperature is 624 Kelvin as we got from here, but as you can see the pressure is, it's not a 0. 2.08 times, but it is 6.24 times. So obvious, I can say from that option D is wrong. D option. One second. Yeah. Option D wrong. I'm not going in an order because as I am deriving, I am checking for the options whichever is matching. So option D has come to a wrong one. Now let us see. Option B was asking the change in internal energy is going from state A to B is. Now I need to keep these things as it is. Now let me erase the portion before that we discussed from here. Yeah, the change in internal energy can be written as from A to B. Change in internal energy from A to B. Delta U A to B can be written as NCV delta T, specific heat of a gas at a constant volume. There we can say 10 times of 3 by 2 R times of change in temperature is like a TB minus TA, 624 minus 300, and that would give me change in AB is 4860 times of R. Yes. So from this we can say option B is correct. Option B is correct. Now let us see for option C, the net change in the internal energy. So that is a total change. The total change in internal energy can be written as again NCV times of temperature at F minus temperature at A. So internal energy is independent of the path forward. We better check from the initial to final. Initial is A and final is a F point. And if I substitute the same manner, so what do I get here again? 10 times of 3 by 2 R. So temperature at F point is, it is a water bath temperature. And how much is that? Let me write here. Temperature at F will be equal to 11 degrees Celsius. That is equals to 284, right? 284 Kelvin. Yeah. So if I can do that, 284 minus 300. That would give me a negative value. So it is a minus. I am getting it as like a overall 240 times of R. Yeah, this concludes that option C is also correct. Option C is also correct answer. Now we need to verify the option A over here, graph, and let me. I can take that. Look at here. If I can draw a graph between pressure versus volume. Yeah, pressure versus volume. Let me say that it is starting from point A. It's a graphs are given like this. Let me say, yeah, starting from point A. Adiabatic process, so it's going to rise up to B point, and isochoric process till C, and it is also going to finally to C, and it is following. The graph looks similar. Let me say, question says like finally it is reached to the initial position. Initial position in the sense maybe a same volume but not the same temperature. So these point A and F no need to be touching each other because here it is a 27 degrees Celsius, temperature at A is like a 300 Kelvin, and temperature at F will be like a 284 Kelvin. That is the reason. And yeah, option A is also correct. That's it. Thank you.
So we are doing paper to question number 10. We have two thin wires. Wire 1's diameter is given and wire 2's diameter is unknown, that is small d. Now we have been given two tables, all right. So first of all, we'll check whether we have zero error in this question or not. So for wire 1, the main scale reading is given as 0.5. So we know that total reading is equal to main scale reading plus least count into circular scale reading, right? Now what is least count? Least count is equal to pitch by number of circular scale division. Pitch in this question is given as can you show me the question? So pitch is given as 0.5 mm and circular scale division is given as 100. So when you solve this, you'll get 1 by 200 mm. So total reading in first question is given as 6.5 or 0.650. So 0.650 mm is given as the reading value, equals to main scale is given as 0.5 mm plus least count we just found out 1 by 200 and multiplied by circular scale division, that is equals to 42. So if both of them comes out to be equal, we'll say that there is no zero error. So let's check. So the RHS value comes out to be upon calculation 0.71. all right, so you see that this value is coming more than this value. All right, so that means there is a zero error, and that is positive because actual reading is lesser than this, so we have a positive zero error. So zero error is equal to 0.71 minus 0.65. So you'll get 0.06. All right, yeah, you'll get 0.06 in terms of mm. Now we'll check for wire number 2. So for wire 2, total reading, question please. So for wire 2, total reading becomes equals to 1.5. The value is given as 1.5 into 1 upon 200 multiplied by 95. Okay, 95 is the circular scale reading. So when you simplify this, the value which you'll get is 1.975. all right, now this is the value with zero error, so we'll subtract this much from here. So true reading, or you can say actual reading, so actual reading AR becomes 1.975 mm minus 0.06 mm. So you'll get the value as 1.915 mm. So in terms of micrometer, you'll get 1915 micrometer. Okay, question please. So I think they asked us the value in micrometer. Yes, so answer becomes 1915 micrometer. Thank you.
So paper 2, question number 11, physics. In a single slit diffraction experiment, a slit of width 0.016 plus minus 0.002 mm is used to measure the wavelength of a monochromatic light source. In the diffraction pattern, the angular distance between the central maximum and the first minimum is measured to be 2 degree plus minus 40 arc minutes, that single dash. The value of the fractional error in the measurement of wavelength is. So they are asking fractional error in the measurement of wavelength. If we know the slit width and if we know the angular distance between the central maximum and first minimum, how do we get that wavelength? We have the formula. I'll just treat it as a formula now. So it was lambda equals a sine theta, right? So if we know the slit width A and if we know the angular distance between the central maximum and first minimum, then using them we can get the wavelength of the light. Lambda equals a sine theta. Now from here we have to evaluate the fractional error in measurement of wavelength. So for fractional error in measurement of wavelength, we have to go with error analysis, right? I'll go with differentiation, so that d lambda will be that error in measurement of lambda, dA will be error in measurement of a, d theta will be error in measurement of theta. So let's differentiate both sides, let's say with respect to theta. So d lambda by d theta on left side, right side it will be product rule. So differentiation of right side with respect to theta, a cos theta plus differentiation of the other part. So sine theta remains as it is, it will be d theta dA by d theta. Sine theta into dA by d theta. So we could get an expression for d lambda, which is supposed to be error in measurement of wavelength. It will be a cos theta and multiply d theta both the terms, d theta plus sine theta times dA. So we get this expression for d lambda. This is the error, but we want to find the fractional error. So fractional error will be the error value d lambda divided by actual value, right? So we get d lambda by lambda as the fractional error, and that we have to divide by lambda. Lambda was a sine theta, so I'll write a cos theta d theta plus sine theta into dA, all that divided by a sine theta. So what do we get for fractional error? A gets cancelled, cos by sine is cot theta, this times d theta plus sine theta by sine theta gets cancelled, dA divided by a. This will be expression for fractional error d lambda by lambda. The question is now just evaluating it. So the given data, what are the values of theta, a and dA? We know dA value is given as 0.002 mm. They have given that error in A. A itself is 0.016. Cot theta, well, we have to evaluate that. D theta is 40 arc minutes. That's the error in measurement of theta. And cot theta, well, we have to evaluate that. They have given sine 2 degree. We have to get cot 2 degree. I'll use that triangle method. So maybe I could draw the triangle here. If this angle is theta, which is 2 degree, then sine 2 degree they have given as 0.035. So opposite side is 0.035. Hypotenuse will be 1 unit, and then the adjacent side will be root of 1 minus 0.035 squared. So cot theta here will be adjacent side by opposite side divided by opposite side. So this divided by 0.035. We can substitute that for cot theta, and then d theta will be 2 by 3 degrees, right? So we have to convert that in radian as well. So let's take care of all these things. I'll start writing the expression. Fractional error in measurement of wavelength, cot theta first of all has to be root of 1 minus 0.035 squared. This is adjacent side by opposite side is 0.035. This is just cot theta into d theta. D theta is 40 arc minutes. 60 arc minutes would have been 1 degree. So 40 arc minutes is 2/3 of a degree. 2 by 3 degrees converted to radians. So into pi by 180. Pi is 22 by 7 and 180 is also there in denominator. This is just d theta, cot theta into d theta plus dA by a. dA value is given as error in A 0.002 divided by A is 0.016. Now when you calculate this 0.002, so this is almost 2 divided by 16, so 1 by 8. So this is 1:8 ratio. Well, when we do this calculation, 22 into 2, 44. This is 35 by 1000. 1000 goes to numerator. The number becomes much bigger, right? 1000 by 180. It still becomes some significant number. So this root of 1 minus 0.035 squared could be just approximated as 1. I could write this as 2 into 22, 2 into 22 divided by 3 into 7 into 180, and what I have to also write is 35 by 1000, all that plus 1 by 8. So rest of the task is just calculation. 1 by 8 is 0.125. Well, and when you do this calculations, you will get somewhere around 0.33 something, right? So when we do this calculation, the overall number will be 0.45. So this was almost 0.34 almost, right? So overall number will be 0.45. So the fractional error in the measurement of wavelength will be 0.45. Now I'm not going to do this calculation. You can do it. The number is coming out to be addition of both of them is almost 0.45. As shown in the figure, a ray AB of unpolarized light enters from water of refractive index 4 by 3 into a medium of refractive index 4 by root 3 after passing through a glass plate of refractive index 1.5 and a layer of water. So they have given water layer again 4 by 3 itself. At a particular incident angle I, the reflected ray CD is polarized in the direction as shown in the figure. The value of I is, so reflected ray is polarized. Maybe we have to use Brewster's ideas, right? So when light goes from one medium to another, it doesn't fully go into second medium. Part of it gets reflected as well. So when the angle of incidence is equal to Brewster's angle, in such case the reflected light is totally plane polarized. So at that third incidence, first incidence was from water to glass, second from glass to water, third will be from water to that new medium P as well again. So that third incidence I'm saying, suppose the angle of incidence there is some I. By the way, how much is that I? If there are number of interfaces parallel to each other and then first medium and third medium are same, then angle into which it goes, the light goes parallel to the first medium again, to the light in first medium itself again. So let's say this is water, then there is this glass layer, then there is again water, and then there is this next medium. So first medium, light was incident at angle of incidence I, then it goes into glass, but when it again goes into water, if the surfaces are parallel, we know the light comes out parallel to the incident ray, so like this, right? So again here the angle of incidence will be I itself. Now with that angle of incidence, the light is getting reflected such that the reflected light is plane polarized from here itself. So here onwards it will be just plane polarized. That is possible if angle of incidence is Brewster's angle. That's basically when the angle of refraction here is such that the refracted ray and the reflected ray, both of them are perpendicular to each other. So this angle of reflection should be I itself again. So we get this as I, that as R, and then this reflected ray will be plane polarized. So we have to write conditions for that. When a total angle on the right, to the right of this line will be 180 degree. So this was 90. I plus R should be 90. R should be 90 minus I. And then we can write the equation for Snell's law between water and that medium P. So for water, refractive index was 4 by 3 sin I. And for P, the refractive index is 4 by root 3 sine of, this is 90 minus I. That's the angle of refraction into medium P. We get 4 cancelled. This root 3. So there will be root 3 in denominator. 1 by root 3 sin I equals sin 90 minus I is cos I. So we get tan I equals root 3. I has to be equal to 60 degree. That's it. The angle of incidence from the water side. This angle and this angle are same. So here itself the angle of incidence should be 60 degree.
Can I? Yeah. Hi everyone. So here we are going to discuss question number 13. In this question, so what we have to find out, the current through this resistor R1. So first in the question they are given, when it is open, when the key is open, the current through this is Ig, which means this is the key. Now this, when the key is closed, we can call it as Ig1, current through the galvanometer. So this is the situation. So we need to find out the current through the R1. So for that, first one we can understand the question they have given this Ig1 is nothing but what it was. Ig1 is nothing but half of the initial current, that is nothing but Ig. Okay, this is the thing. So when it is open, the current will be what? The current will be flowing through here only, right? When the key is open. So you can find out what the resistance. The resistance will be what? The resistance will be nothing but Ig. This is the current going through the. So whatever the EMF of the battery, EMF is 10 volt. So 10 divided by what we have to do, we have to calculate the total resistance. What about the resistance? Resistance of the galvanometer and this R1. So it will be R1 plus resistance of the galvanometer. This will be 10 by R1. We don't know, but we know the resistance of the galvanometer. It is given in the question, that is nothing but 6 ohm. So we got Ig. Now when it is connecting, here there will be the resistance of the galvanometer, or there will be R2. Then that will be in parallel. For that parallel combination, what will be the resistance? Resistance will be R2 into Rg divided by R2 plus Rg. So that will be Rp. Rp will be equals. So R2 is given, that is 4 ohm in the question. And what about the Rg is 6. So we will be getting 6 into 4 divided by 6 plus 4. That will be equal to 2.4. We got the Rp. And what about the total resistance? Total resistance means this parallel combination as well as this one, right? So the total resistance R will be equals R1, but we don't know, that is 2.4 ohm. This will be the total resistance. Now what we have to do? We have to find out the current through this R1. Let's say R1 is the current through the R1, resistance R1. So what we can do? That will be equals the potential difference or the EMF of the battery divided by what? Total resistance. That will be R1 plus 2.4 ohm. So if we are able to find out this R1, then we can get what? We can get the value of IR1. So now here we can say the current is coming and going like this. So current through R2 plus current through this galvanometer in what condition? In the closed condition will be equal to what? IR1. From here we can find out Ig1, that will be equals IR1 into R2 divided by Rg plus R2. So how we can do this? This IR2 you can convert in terms of our Ig1, then you can get this relation. So you got Ig1 here. Ig1 is nothing but Ig by 2, that equal to IR1 into R2 is nothing but R2 we got. R2 is nothing but what it was, R2 is 4 ohm. Then divided by 6 plus 4, we got it here. IR1 we already have here, that will be equals 10 divided by R1 plus 2.4 into 0.4, that is nothing but Ig by 2. Ig already we have. What is Ig? Ig is 10 by R1 plus 2. If I am dividing it with the 2, what I will get? This become 5, right? So 5 divided by R1 plus 6. This will be the, if I am solving, I will get R1. If I am getting R1, I can find out the current through the R1 resistance, R1. So here it will be, so if I am multiplying this, I will get 5 times R1 plus 12 equals, this become 10 into 0.4, 4 it will come, 4 times R1 plus 24. So R1 will be equals 12 ohm. So I got R1. Now you can substitute in that equation. So here we can erase this and we can substitute for that. So IR1 will be equals 10 divided by R1 is nothing but 12 plus 2.4. You will get 10 by 14.4. This will be equal to 0.69 for it will go like this. So in milliampere, IR1 will be equal 694 milliampere. So this will be the answer. So thank you everyone.